Our next problem is x to the 2nth power minus y to the 2nth power is divisible by x plus y. And we gotta prove this. So how can we use mathematical induction? Well, our first step, as always, is to see what happens if n is equal to 1. If n is equal to 1, we have x squared minus y squared. And we can rewrite that as x plus y times x minus y using our square difference formula. And as you can see, this is divisible by x plus y. So then when n is equal to 1, this statement is true. So then our next statement is to say, okay, well, n equals 1. That's true. Then we're going to assume that when n is equal to k, so any integer, x to the 2k minus y to the 2k is equal to a multiple of x plus y. So we're going to assume this and then build off of our assumption from here. So then if this is true, if n is equal to k and this is true, then when n is equal to k plus 1, will this still be true? So this is where we have to actually write it out and calculate it. So we have x to the 2 times k plus 1 power minus y to the 2 times k plus 1 power. And just so you know, our goal is to simplify this expression down to where we have something multiplied by x plus y. So we can go ahead and make it x to the 2k plus 2 power minus y to the 2k plus 2 power. And then we can write x to the 2k plus 2 minus x squared times y to the 2k. And then, just so you know, this term, we're making it up ourselves. So then if we make it up ourselves, it means we still have to add on x squared times y to k to cancel it out. Minus our original y to the 2k plus 2 power. So if you look at here, we've essentially just came up with our own terms to help ourselves. So then if we make up this term, we can factor out an x to the second power. X to the second power gives us x to the 2k minus y to the 2k plus this x squared times y to the 2k power minus y to the 2k plus 2 power. And as you can see, we did this distributive property and factor out the x squared just to get this x to 2k minus y to the 2k. And when we look back at our assumption, we see that when n is equal to k, this value holds true. It's equal to m times k plus y. So we can rewrite it as x squared times m times k plus y. And over here on the right, we can factor out a y to the 2k power, which gives us x squared minus y squared. This gives us x squared times m times x plus y to the 2k power times x plus y times x minus y. And look, we see both sides have an x plus y. So we could go ahead and factor that out. We have x plus y times x squared times m plus y to the 2k power times x minus y. And there we go. We are left with an expression that has x plus y as a factor, which means that when n is equal to k plus 1, it is divisible by x plus y.